Welcome to the second lecture in the module 4 in the subject material of mechanics of material. So in the previous class we started learning that how to calculate the deflections in a truss system. So in the last class how we calculated. Initially we calculated the strain energy in the whole truss, and then we used Castigliano's theorem and differentiated the strain energy with respect to a force. The force was applied in a direction in which deflection was required. So we were following that kind of thing. So this is what we did. We calculated the strain energy, and then we differentiated the strain energy with respect to any force, and then what we were getting delta at point C in the direction of F, or the force applied. So this is what we did in the last class, but what problem we faced, that whatever we were calculating, see here, so whatever term you calculated, there was P in every term. So you have a lot of stuff or a lot of numbers to calculate in every single step. So this is a slightly lengthier and tedious task to do. So we need some better way to calculate the deflection, in which this problem of heavy calculation or heavy or large number of the terms can be reduced. So this is what we want. So how to come with this solution? Then we have one more method for calculating the deflections, and it is same as strain energy, only a slight improvement is there. And this new method is called unit load method. Okay, it is same as strain energy, but a little bit different from strain energy. So let's start. So let's start. So let's bring in the concept from strain energy, in which we already studied that differentiation of U with respect to any force, let's say P, gives deflection at point C in the direction of P. So this is what we were getting. So we can further reduce this calculation. So let's reduce it. So what was U? U was summation from I from 1 to n, then pi square li, then a dot e. Okay, this was the basic substitution or basic fundamental formula for this calculation of deflection. Now if you further differentiate it, what will you get? You will get summation I from 1 to n pi dot pi by dp dot li, sorry, here it was 2, so this 2 will be there, 2 ae, so this 2 and 2 will cut themselves and they will disappear, and deflection will be something like that. Okay, so now you see this is the pi is what force in every member, and this is what differentiation of force with respect to P. Now in unit load method this can be reduced in one better form, and this term is written as this term is written as K. Okay, what is K? We will come to that. So if you will substitute this differentiation part with respect to K, our equation will be pi k L divided by AE, which is nothing but delta C in the direction of P. So your formula will transform in this manner. So what is Pi here? Pi is member force in member I. AI, it is AI. AI is cross sectional area of member I. Similarly, what is EI? EI is Young's modulus of member I, and now is this term K, so we will represent it also as I. So I is also member force in member I when unit load is applied. So what is Ki? Ki is also member force, but on a certain condition, and the condition is when unit load is applied. Okay, so this is how you are going to change your approach for the question, and you will be easily or with lesser calculation you will be calculating the deflection. The method that we used in the last class, if you will solve a question which is having 4 to 5 panels, then you will have a huge calculation in it. So it will become very, very difficult for you to solve it very correctly. Somewhere you may commit mistake. So this problem can be removed by unit load method. So you might not be getting this right now. So let's solve the problem, or let me solve the same problem that we solved in the previous class. So let me draw the diagram again. So the question was, find horizontal deflection in truss at C. So our truss was like this. Here was roller support, here was hinge support. This was point C, this was point A, this was point B. This was 3 meter. Let me check. So this was 3 meter, this was 4 meter, this was 5 meter, and here one load was applied of value 20 kg. So this is the same question that we solved in previous class. Now we will solve the same question by the help of unit load method. So what do we need? We need all the value of PIs. We need all the values of KI and length LIs, AI and EI. For every member we need these values. So out of which EI and AI is already fixed for all the members. What is A? Area is 600 mm square, and EI is 2 into 10 to the power 5 Newton per mm square. So for all the member we know these values. All the length we also know, 4 meter, 3 meter and 5 meter. Only two things we don't know. We don't know PI values and KI values. So we will be calculating the PI values. So what is PI? PI is the member force that is for this truss, okay, for this loading condition. Okay. So what you have to do, you have to simply find the values of forces. Okay. So although we have already calculated this value, but let me solve again. And so first we will be calculating the reactions. Let me remove this. So let me calculate the reactions. So first equation that I am applying is summation of forces in x direction is 0, and sign convention that I am taking is this one. So what are the horizontal forces in the system? Only one force is there, HB. So HB, which is in negative direction, so the value of HB is 0. So I have calculated first reaction, this value is 0. Now let's find another reaction. So which equation I can use? I can use any equation. So let me use this equation. Summation of moment at point B is 0. sign convention that I am taking is this one, this side positive, this side negative. So let's solve it. So first is VA. So VA perpendicular distance 4. What is the direction? It is clockwise, so positive. Then what is next force? 20 kilonewton. 20. Perpendicular distance again 4. What is the direction? Like this up to B. So like this, so anti-clockwise. So minus is equal to 0. From here you can find out that VA is nothing but 20 kilonewton. So the value of VA comes out to be 20 kilonewton. Now you have calculated two reactions. So let's calculate another reaction also. So let's say I am writing the equation summation of forces in y direction 0. Sign convention upward positive, downward negative. Let's solve them. So what are the vertical forces? First one is VA. What is the direction? Upward. So positive 20. What is next force? 20. What is the direction? Downward. So negative 20. What else is there? VB. So positive VB is equal to 0. So from here you will see that VB comes out to be 0. So this is 0. So now we have calculated all the three reactions, okay, out of which one is 0. Now what we are required to do? We are required to find the value of PIs. What are PIs? Are the member forces and force in these three members. So let's start calculating them. Before that, check whether there is any zero member force here. So you can observe that you can observe the condition at joint A, okay, and you will realize that this member AB is zero member force and the value in the member AB will come out to be 0. You may solve it also or you may identify it right now also. Okay. So I have identified and this will reduce my calculation. Okay. Now I will start solving. So from where I can solve? I can start from the joint A. So let's start. So at joint A, what is the condition at joint A? At A, the system is like this. Here VA is there, its value is 20 kilonewton. Here B is there, this is a zero member force, and upside there is point C. Let us say initially the joint is in tension. Let us assume that force in this member, let us say it is AC. Okay. So this is the initial condition of joint. Let's start solving now. Which equation I can apply? There are only two vertical forces. This one is 0, so I can simply use summation of forces in vertical direction 0, upward positive, downward negative. And if you will solve this, so you can write it. VA's value is 20 kilonewton upward. FAC is also upward, so positive. FAC is equal to 0. From here you can find out that value of FAC is nothing but minus 20 kilonewton. Minus sign indicates that this member is in tension. So now you have calculated this value. So let's put it. So we have calculated this value. The only value required is this one. So let's come to the joint B. So at joint B, so draw the condition of joint B. So this is a zero member force, and let us assume this member is in tension initially. So this is the condition. So now we can start applying the equilibrium at the joint. So which equation we can apply? So let's apply summation of forces in y direction is 0. So what is the vertical forces here? So first vertical force is VB, which is 0 itself, so we don't have to worry about this. This is 0, this is 0, this is 0. Only force left is FBC, and its component in the vertical direction will be something like this. Let us say this is some theta, so this component will be FBC sine theta, and no any other member is there. So from here you will find out that FBC also is 0. So now you have calculated that FBC is also coming out to be 0. So this will reduce my calculation. So from here this member was also 0. So I have calculated force in all the three members. So let me write here member PI value, KI value, LI value, AI value, and EI. So first member was AB, then AC, and then BC. So out of these three members, this AB was 0. This BC also came out to be 0. Okay. And what was the value of AC? It was 20. Let me check again. So it was minus 20. So it was minus. So we have calculated all the values of PI. Let me write this value also. This value was 600, 600, 600. In unit was mm square. Its unit is Newton per mm square. So this value was 2 into 10 to the power 5, 2 into 10 to the power 5, 2 into 10 to the power 5. Okay. What were the values of LIs? AB was 3 meters, so let me write it in the unit mm. So it was 3000 mm. Then what was this was AB was 4 meters, so it was 4000. AC was 3 meters, and DC was 5 meters, so it was 5000 mm. So this much we know now. We only need the Ki values. So let's start finding the Ki values. So let's start finding the Ki values. So what are Ki values? Since we are studying unit load method, so now we have to apply a unit load. Unit load means load, the value of load should be 1 unit. Okay, so let us apply, draw the initial diagram. This was our initial diagram. This is our initial truss system. Okay. Now, when you want to find the Ki values, you should draw the truss and you should remove all the load that were initially applied. Okay. So I am not applying any load that was given in the question. Okay. Rather, I will apply load in the direction in which deflection is required. So see here, the question is asking find the horizontal deflection in the truss at C. So earlier I was applying a pseudo load at C in the horizontal direction. Okay. Now I will not apply pseudo load. Rather I will be applying a load of 1 unit. And what is the direction? The direction is the same direction in which question is asking that find the deflection in this direction. If they will say vertical direction, I should have applied this unit load in this direction. But since the question is asking deflection in the horizontal direction, so I am applying a unit load in the horizontal direction. So this is how you should apply. Okay. So now this is your new problem, and you have to again find the values of member forces in this truss. So let's start solving this truss. Again you have to calculate VA, again you have to calculate VB and HP. So let's start. The first equation that I am using is summation of forces in x direction 0. Sign convention is the same. So how many forces are horizontal? 1 unit. What is the direction? This side, so positive. Then HB, what is the direction? Minus x side, so minus HB is equal to 0. From here you can find out that value of HB is 1 unit. Okay, so you got value of HB which is 1. Then next let's start solving for other reactions. So I am using this equation. Summation of moment at point B is 0. Sign convention, clockwise positive, anti-clockwise negative. So let's write the equation. VA perpendicular distance, this was 4 meter, this was 3 meter, this was 5 meter. So this is 4 meter. Then what else force is there? 1 unit. What is the perpendicular distance? 3 meter for the point B. So 1 unit perpendicular distance 3. what is the direction? It is clockwise, so positive. Equal to 0. So from here you will find out that VA comes out to be minus 3 by 4. So I have calculated this value also. This is minus 3 by 4. Now I can do one thing. Either I can keep this value as minus, or I can also change this. This is also correct. Okay, I can also change this as this PB is equal to 3 by 4. Okay, I have removed the minus and I have changed the direction. So you can use either of the thing. So let's stick to this one. Basically you can do both. Okay, so let's stick to this one. Let's remove this one. Okay, so I am not using this, but you can use any. So now I have calculated VA also. Now sorry, this one is VA. Sorry. VA was this one, minus 3 by 4. Okay. So this is VA. Now I need to calculate the value of VB. So I am using this equation. Summation of forces in the vertical direction is 0, upward positive, downward negative. So what is the force? VA. What is the direction? Upward. So I have to use minus sign, minus 3 by 4. What else is there? VB. What is the direction? Upward. So VB. From here I will find out that value of VB is 3 by 4. So I'll put it as 3 by 4. Or if you want to remove this, you can also write VA as equal to 3 by 4, and then you have to indicate direction downwards. Okay, so I will be using this one only. So let's start finding the KI values. So what are KI values? They are also member forces, but when the unit load is applied in the truss. Okay, so we'll start finding the value. So from where we can start? I think we should start from the joint A. Why? Because I can clearly observe here that from here this is coming out to be a 0 member force. Okay, so its value will be 0. So I will have only two forces to calculate. So let's start from joint A. So at joint A, what are the values? What are the condition of the joint? And what was the value of reaction? It was like this. VA, its value was minus 3 by 4. So this was 0. Let us say the force in this member is FAC. Then you can find it simply. You can use this equation. Summation of forces in the vertical direction is 0. Sign convention, upward positive and downward negative. So start writing the equation. The value of VA is, direction is showing upward, thus minus sign upward, and its value is minus 3 by 4. So minus 3 by 4 and 3 by 4 and its direction is upward. Okay, so what else is there? FAC, what is its direction? Its direction is also upward, so positive. So from here you can find out that value of FAC is nothing but 3 by 4 unit. So you have calculated one values. Okay. Now you can calculate other value also. So how should you calculate? So let's go back and see from where you can calculate. You can start from the joint B. So let's solve here itself, that at joint B, what was the condition? FBC, this was 0, so we don't have to worry about this. Here the vertical force was VB, here it was HB. The value of HB was 1 and the value of PB was 3 by 4. So let's put it there. So this was 3 by 4. What is your target? Your target is to find this value. So which equation you can use? You can use either equation. Let me use this equation, summation of forces in the let's say in the horizontal direction is 0. This side positive, this side negative. So what are the horizontal forces? HB. What is its direction this side? So it is minus. Value of HB is 1. What else is there? FBC. Its component in the horizontal direction. So what will be component in horizontal direction? FBC into cos theta. What is its direction this side? So minus. So from here you can calculate the value of FBC is minus 1 divided by cos theta. Then what is the value of cos theta? This was 4 meter. This was 5 meter. This was 4 meter. So cos theta is base divided by hypotenuse. You can substitute. So base was 4, hypotenuse was 5, just minus 1. So the value of FBC is minus 5 by 4. So these values of member forces are nothing but KI values for our requirement. So we can put these values. So let's go back to this one and let's go back here, and we need to substitute here the value of member forces when unit load was applied. So what was the value of AP was 0. What were the other values? AC was 3 by 4. So AC was 3 by 4 and BC was minus 5 by 4. BC was minus 5 by 4. Now this is your basic table for calculating the values. So you can find the deflection at say in the horizontal direction, how it was calculated. I21 PI KI LI divided by AI into EI. Okay, you have to sum all these values. So what is the PI? First PI is 0, KI is 0 and multiplied by this one divided by this two one. So since it is multiplying by 0, the first term will be 0. Come to the AC. What is the value of PI? Minus 20. So minus 20. What is the value of KI? 3 by 4. So its value is 3 by 4. What is the value of length for this member? 3000. So 3000. What is the value of AI? 600. So 600. What is the value of EI? 2 multiplied by 10 to the power 5. So we have calculated for the AC. Then come to the BC. See here, it is value of PI is 0. So 0 multiplied by this much term will come out to be 0. And then you can solve this one. So let me calculate. So 20 multiplied by 3 multiplied by 3000 divided by 2 divided by 600 so its value comes out to be 0.000375. So this is the value of deflection. Okay, see here, this is minus sign is there. What does minus sign indicates? It indicates that deflection is in the downward direction. Why? Because our sign convention said upward positive, downward negative. So negative means what? Downwards. Thus this deflection is also in the downward direction. So in this way you can solve your simple question, and although you will be required to solve the truss 2 times, almost 2 times, but when you will be doing a lengthier question, you will realize that you can solve in a less time as compared to your strain energy method. Okay, so unit load method will help you to find the value in a more faster way. So this is all about today's class. We'll meet in the next time. Thank you very much.